Hi, this is Mrs. Cribb. If you have not done so already, I need you to go print out the specific heat practice problems worksheet, and also you will need to print out the reference sheet. So let me show you the reference sheet. Here it is. Looks like this, chapter 13 reference chart. It's 2 pages long. Okay, and some of this you'll use in this video and some you'll use later, and some you may not use at all. Kind of depends on what we're doing and which class you're in. Okay, so back to this. So we're going to use that. Now we're going to start here. The formulas we're going to use primarily are this one. Q stands for joules, and it's an energy unit. Okay, joules of energy. It might be kilojoules, but it's mostly joules. M is mass in grams, and I know that in last chapter it was molality, but this little m is stand for mass. C is the specific heat. And you can write these little notes on your worksheet. That would be fine. And delta T is the change in temperature in degrees Celsius. Okay? Now delta T is also equal to the final temperature minus the initial temperature. So we'll have to use that together. So we're going to use these. Now, how much energy? There's the question. So that's the question, and that's the Q. Must be absorbed by 20 grams of water. Now, you also have to know it's water. To increase its temperature from this to this. So this is going to be the initial temperature. It goes from that to the final temperature. And now the water vapor you're going to use here, you're going to use the specific heat of water vapor or steam. Okay? And that's 2.01 joules per gram degree Celsius. And this right here can be written as 2.01 joules per gram degree Celsius. That's what it means. This is this unit that's used. So this one is just, I want to calculate Q, so that's what I'm looking for. So Q equals MC delta T. And it's an easy one to memorize because of the rhythmic sound of it. All right, so we have the mass of this water, and it's 20 grams. And the specific heat value I just gave you, 2.01 joules per gram degree Celsius. So delta T is the next thing that we have to do, and I'm going to calculate it and put it in this spot. So delta T is the final temperature minus the initial temperature. It's always the change in something is always the second one minus the first one. So 303.0 degrees Celsius minus 283.0 degrees Celsius, and that ends up giving me 20.0 degrees Celsius. I want you to notice that the temperatures go to the tenths place. So we have to keep the tenths place when we do the math. This one has 4 significant figures. And this one also has 4 significant figures. But this number only has 3 significant figures. And it's because of subtracting, we go to place value. We don't count them. So we put into this formula the 20.0 degrees Celsius. I'm going to go ahead and cancel out units. Grams in the numerator, grams in the denominator, grams in the denominator, degrees Celsius, and degrees Celsius again. And when I do this math, 20 times 2.01 times 20.0, I get 804. And I have to double check my significant figures. Remember, significant figures do not come from a chart. I'm going to write that up here. Sig figs do not come from a chart. They come from measured values. So this is a chart, so it wouldn't come from that. This is a measured value, the 20 grams, and the degrees Celsius is a measured value. Both of those have 3 sig figs, so I needed 3 here. So 804 joules, because the only unit that I didn't cancel out is the answer. And remember, joules is an energy unit, so that is the correct unit for this particular question. All right, I'm going to pause here. And now you're going to do one on Edpuzzle. So I'm just going to write this here to remind myself. Okay, now we're going to move on to number 2. 15 grams of steam drops in temperature from T1, 275 degrees Celsius, to T final, 250 degrees Celsius. How much heat energy, again, energy is a Q, is released? How much energy is released? Okay. Now use the same C value from above. Now the other thing is I wanted to show you on the reference chart here. Let me pull the reference chart back up. There we go. Here's this reference chart. There are specific heats of ice, so that's just solid water, liquid water, and steam, which is water vapor. Notice that their specific heat values can be slightly different. This time we're using the steam one, and a lot of times you'll use the water one. You'll need to look at that. If you have a question about which one to use, look for the state of matter of water in the question. Water down here is 4.18. Water up here is 4.184. So both of those would be for liquid water. This one just has more decimal places, and we generally use this one for water. And it just that way, I put this chart here for all these other guys that might be used. Okay, back to here. All right, so it's still looking for the Q, so we're going to still use Q equals MC delta T. And remember, I am, here we go. See this? I'm writing the formula, and I wrote this formula with no numbers written in it. You have to do that. That is part of the work. Remember, I give you the formulas, and so your part of the deal is to write the formulas using the reference sheet. Otherwise, I will stop giving you reference sheets and you'll have to memorize all the formulas that we use. And I think that's a little more difficult. Okay, so let's go back. We're going to fill this in. We have 15 grams. That's the mass again, 15.0 grams. You must put all the significant figures and the unit in its place. The C value, it says that use the same one as you used up here. So 2.01 joules per gram degrees Celsius. And then we have to do the T final minus T initial again. So I'm going to write that over here. T final minus T initial. I'm going to put those in. 250.0 degrees Celsius is the final temperature. The initial temperature is 275.0 degrees Celsius. Okay, we subtract those out and we get a negative 25.0 degrees Celsius. And it's negative because the temperature drops. When the temperature drops, the temperature is going down. That means you have a negative change. Okay, that should work out if you chose the correct T final and the correct T initial, which that is. Now we're going to substitute this into the spot where the delta T is, negative 25.0 degrees Celsius. Again, this one has 4 sig figs. This one has 4 sig figs, but we have to go to the tenths place because that is the place value, and that is what you do when you're doing subtraction and addition. Now we're going to cancel out units, grams and grams, degrees Celsius and degrees Celsius. The unit that didn't cancel is joules, which is good because that is the unit that I need. And now I multiply 15 times 2.01 times a negative 25.0, and the answer that I get is negative 753.75. This would be my raw answer, and I'm going to check for sig figs again. Remember, significant figures don't come from a chart, so it's these 3 numbers, that's 3 sig figs. These 3 numbers, that's 3 sig figs. So I need 3. 1, 2, 3. So I look at the 7. It causes that 3 to round up. So it's negative 754 degrees Celsius. Well, this is the Q value. That is the change in the Q value. Now, this is one of those times you got to be careful. If I just asked you what was the energy when this happened, this would be the right answer. But here I asked you what was the energy that was released. You're losing this amount of energy, so you released a positive amount. So the energy released is 754, oops, not degrees Celsius, joules. 754 joules. Now, how do we know which one to do? That becomes a question. If I tell you that the amount of money I had was $100, and the change in the amount of money I had was, the change in my money was a negative $25, so now I would have $75. That's my new amount, okay? So the change in my money was a negative $25. That. Well, how much money did I release? How much money did I let go of? How much money did I lose? I lost $25. I didn't lose a negative 25. I lost $25. That losing $25 is a negative 25. I hope that helps. You started with a 100. The change in the money was a negative 25, so the final amount was $75. Or how much money did you lose, or how much money did you release? I released $25. I released 754 joules of energy. What was the change in the energy? A negative 754 joules. Be careful how the questions are worded. Okay, now we're going to do an Edpuzzle question. Okay, now we're going to move on to number 3. How much energy is required to heat 120 grams of water? And so in this case, because it just says water, we're talking about liquid water. From 2 degrees Celsius, that would be your initial temperature, to 24 degrees Celsius, that would be your final temperature. So how much energy is required? That is your Q. All right, I'm going to let you do this one on your own. The one thing I wanted to point out is you're talking about liquid water now, so you need to look at your reference sheet. There's liquid water, so the Q, the specific heat rather, the C is 4.184 joules per gram degrees Celsius. Okay? So let me go back and write that on there for you. See the reference sheet for the C. The C is 4.184 joules per gram degrees Celsius, because we're talking about liquid water. Okay, I'm going to have you do this one. And when you get done, enter your answer on Edpuzzle and make sure you show all your work, because this is part of what you're going to turn into me later. All right, now we're going to go on to number 4. Let me tell you just one thing. I will give you the answer for this one just so you know. The answer is 1.10 times 10 to the 4th joules. And that is, you could have written it as also 11,000 joules. Both of those are correct. I didn't ask for scientific notation, but this is the correct number of significant figures for this particular problem. Okay, number 4. How much heat, okay, again, in joules, so that's still the Q, is given out when 85 grams of lead, this time, cools from, there's your initial temperature, to your final temperature. And then I gave you the specific heat of lead, 0.129 joules per gram degrees Celsius. Okay, this again is using the same type of formula. It's asking for Q. Q equals MC delta T. Delta T. I don't know what I just wrote there. Delta T. Okay, the mass of lead is 85.0 grams. The specific heat of lead is different than the other one. So 0.129 joules per gram degree Celsius. And the delta T, so I'm going to calculate delta T. D final minus T initial. So that's going to be 10 degrees Celsius minus 200 degrees Celsius. So that the delta T equals, negative 190.0 degrees Celsius. All right, again, let's look at the significant figures. This one has 3. This one has 4. 3 sig figs, 4 sig figs. But we're subtracting, so we go to the 10th place. So this one has also 4 sig figs. So negative 190.0 degrees Celsius. And then you do the multiplication, 85 times 0.129 times 190, and I get negative 2083 as my raw number. And then I have to look for significant figures. Okay, so sig figs here, 3 significant figures. This is a chart value, 4 sig figs. So I need 3 sig figs, 1, 2, 3. I look at the 3, the 8 doesn't change, So it's negative 2080. Okay, and that's joules, because the joules won't cancel, the grams cancel, and the degrees Celsius cancels. So this is the Q value. How much heat is given out? Now, this is the change in the Q. How much is given out? Again, that's like how much did you lose? I lost. How much is given out? Well, I gave away 2,800 joules. Just like I gave away $25, I gave away 2,080 joules. I know that's confusing a little bit. Just think about it. This Q here is really the change in the heat. The change in heat. This is how much is given away. All right. I'm going to let you do another one now on Edpuzzle. All right. Now we're going to do number 5. Number 5, it takes 41.72 joules to heat a piece of gold. Now gold is AU, weighing 18.69 grams from T initial, 10 degrees, to T final. What is the specific heat of gold? I'm calculating the C this time. Now I still use the same formula because I still have joules in there, mass in there, and temperature. So I still have Q equals MC delta T. But now I don't fill it in as I did before. Where does the 41.72 joules go? That is the Q value. Remember, Q is the change in the heat, and that's in joules. So this is going to be 41.72 joules equals, the mass of gold is 18.69 grams. The C is what I'm calculating. That's the specific heat. The delta T is what goes there. So I'm going to calculate the delta T. So T final minus T initial. Okay, so I put those in. 27.0 degrees Celsius minus 10 degrees Celsius. So that should be 17.0 degrees Celsius. And 3 significant figures. So 17.0 degrees Celsius. And now I just multiply it through, or actually I solve for C. So how do I solve for C? This is my question, and I need to isolate the C. Here's the C. I need to isolate it. Okay, so I'm going to divide by 17 degrees Celsius on both sides. And I'm going to divide by 18.69 grams on both sides. I know it's kind of cramped. All right. This will completely cancel. That will completely cancel. So C is going to be equal to 41.72 joules divided by 17.0 degrees Celsius, and also divided by 18.69 grams. Notice that none of these units, joules, degrees Celsius, and grams, none of them will cancel. That's okay, because I'm looking for the specific heat value. And specific heat, look at the units for specific heat: joules, grams, and degrees Celsius. All right, so I put this in, 41.72. I divide by 17, and I divide again by 18.69, and I get 0.131 joules per gram degrees Celsius. 3 significant figures, because all of these things are significant figures. I measured the mass, I measured the temperature, and I measured the joules. So that's the final answer there. Okay, now we're going to do an Edpuzzle question. And one more question to go on this worksheet. Okay, a certain mass of water, so a certain mass, so there's my question, was heated, and it's water, so we're going to talk about liquid water again, was heated with 41,840 joules. Raising the temperature from the initial temperature of 22.0 degrees Celsius, to the final temperature of 28.5 degrees Celsius. Find the mass. All right, Q equals mc delta T. All right, I'm asking for mass. So what's the Q? This is the Q. 41,840 joules. Mass is what I'm after. What is the specific heat of water? So if I look at my reference sheet again, water, liquid water, there it is, 4.184 joules. So that's the value you're going to use. 4.184 joules per gram degree Celsius. And I need the delta T. So delta T is T initial minus T final minus T initial. The final temperature is 28.5 degrees Celsius. The initial temperature is 22.0 degrees Celsius. When I subtract those two, I get 6.5 degrees Celsius. Now again, sig figs, this one goes to the tenths place, this one goes to the tenths place, so I go to the tenths place. So 6.5 degrees Celsius. And then now I have to solve for m, so I got to isolate m. So I'm going to divide both sides by the 6.5 and by the 4.184. Sorry about that. Okay, so mass then is going to equal 40.
I didn't get that. Could you try again?
Sorry about that again. All right, mass is going to equal 41,840 joules divided by 4.184 joules per gram degrees Celsius. I'll go ahead and write that. And also divided by 6.5 degrees Celsius. So see, I'm dividing by this over here. And I'm divided by that whole quantity over here. And that's what I just wrote it on this side so you could see it. Okay, now let's cancel units. Joules, joules, degrees Celsius, degrees Celsius. Grams doesn't cancel. That's what a mass unit is. When we put it all into our calculator, we get 1,538. And we got to figure out significant figures. 2 sig figs here. There's 5 sig figs. Well, no, that's not right. 4 sig figs here because leading zeros are losers, but this one is also a trailing zero. You go in from the Atlantic, and then this one doesn't count as a sig fig, so we need 2 sig figs. So we got to go to there. So 1,500, and the unit is grams, and that would be our final answer to this one. Okay, we're going to do one more question on Edpuzzle. I hope this helps. Please make sure you filled all this into your worksheet. I will see you soon.